not so date. Unless you go to the registration department, the people are so smart, they can even manipulate that information. Okay? So it was introduced way back in 1991 for making this stamp papers, notaries, tamper proof. So intended to timestamp digital documents so that it is not possible to backdate them or tamper them. Left unused until it was adopted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. So many people think that blockchain is only related to Bitcoin, which is not the case. The Bitcoin is developed using the technology of blockchain. I can use this blockchain for any industry. So there is no there is no limitation as such that I have to use it only for the financial sector or to the revenue sector or to the transport sector or to the space. No. It can be used for any industry without any challenges. So the same thing which I have discussed. Is the person Satoshi Nakamoto. He was born in 1975. He is not a very old guy. He is just 47, right? He is a Japanese by nationality. He is known for inventing Bitcoin, implementing the first blockchain, deploying the first decentralized digital currency. Decentralization. Okay? The same concept we are going to use in the blockchain. This is also called as a distributed ledger. So a blockchain is a distributed ledger that is completely open to anyone. So it is not by one particular industry one particular company that they have to take a license to use it. Not like a database by Oracle. Because database is owned by Oracle, right? So if anybody wants to use Oracle database, they have to take a license and use it. But the blockchain as a technology is not the case. Anybody can use this technology. They have an interesting property. Once some data has been recorded inside a blockchain, it becomes nearly impossible to change. We'll see how it is going to work. So in this block there are three items. One is data, second one is hash, the third one is hash of a previous block. Okay, why that hash of a previous block is required? Hash is nothing but an address, right? In the digital terms it is called as a hash. Yes? One is data, for which I have to use. Because why I am using blockchain to store the data, right? So data component is very important thing. Second one, we are talking about a hash. Hash is nothing but an address. Then why we need the hash of a previous block? How many of you learned this linked list? Linked list, right? Why we call it as linked list? The list is connected, right? The blocks are connected there. The data is connected. That is the right reason we are calling it as a linked list. So in the linked list, what is that? We have, it is a connectivity that we have. The connectivity is maintained by this hash of a previous block. So why I am calling this as a blockchain is, the block is getting connected through this hash of a previous block. So that is the reason we need a hash of a previous block to have the connectivity. Data that is stored inside a block depends on the type of the blockchain. If it is a financial data, it is going to be the numbers. If it is something related to the registrations, it is going to be the registrations data. So even in the registrations for the commerce done through this blockchain technology in Aeronautical. people, I don't know if the people, if you know it or not. So the registrations were done because it is something like it is starting new, right? So the agriculture lands were getting converted to the plots. So they started new. So they started to give these registrations in the form of a blockchain. There the data is going to be the registrations data. Okay. So anything based on the industry for which I am using this blockchain, my data is going to differ. So data can be anything. If it is for a Bitcoin, then it is going to have from, to and the amount. If it is for a Bitcoin, this is the information that it may have. I am not saying this is the information that it is going to have, but it may have this information. From, to, and what is the amount that is getting transferred. So this complete data, I can call it as a data in my block. The Bitcoin blockchain, for example, shows the details about a transaction here, such as sender, receiver, and amount of coins. Clear with this? So I am just giving you an example for a Bitcoin. And hash is nothing but the address of this particular block. Hash is nothing but the address of this particular block. Okay. So how my address is going to be created? How my address is going to be calculated? I should not say it's created. How my address is going to be calculated is with the data that is there in the block. Okay. It identifies the block and all of its contents, and it is always unique, just like a fingerprint. That is the reason I am showing that fingerprint here. Okay. So this is unique. This block address is unique. This hash is unique. Okay. Once a block is created, its hash is being calculated. Once a block is created, hash is going to be calculated. What does it mean? So based on the data, so if I have some ABC as a data in my block, then the hash is going to be something different. If I have the small letters ABC, again the hash is going to be different. If I have a dot, ABC dot, my hash is going to be different. What it says is, based on the data that I am going to have in the block, my hash is going to differ. Even if I add a dot, even if I add a comma, even if I add a small character, then my hash is going to change. We will see that. Changing something inside the block will cause the hash to change. That's what I said. So even if I change from small letter to capital letter, or even if I add a dot or a comma, my hash is going to be changed. So this is the beauty of a blockchain. So initially I said it is a tamper-proof, right? Whatever the data that is there in the block, we cannot change. The reason is this: if we change, my hash is going to be changed. Okay. So in other words, hashes are very useful when you want to detect changes to the blocks. So if the fingerprint of a block changes, it is no longer the same block. Okay. As I said, if my data which is there inside, if it is changed, my hash is going to be changed. If the hash is changed, automatically the address of this block is changed. It is not the same block. Hash of the previous block. So we have discussed data, we have discussed hash, and we are also discussing about a hash of a previous block. It is only for the third element inside each block is the hash of the previous block. This effectively creates a chain of blocks, and it's a technique that makes a blockchain. So only with this help of hash of the previous block, the chain is going to establish. Okay. So what does it mean? So for the first block, we will not have anything in the hash of the previous block. But for this block, we will have data, we will have hash of this block, and we have hash of this block in this hash of the previous block. Means that is how the block chain is going to be created. We will see that with an example. So take an example. This is the hash, means address of this block, first block. Address of second block is this. Address of third block is this. Clear? The first block, previous hash is 0, 4 zeros. Because this is the first block, I don't have any previous block there. Okay? If you see this second one. Whatever the hash of the first block, that is going to be there in the hash, previous block hash of the second block. So this is the data, this is the hash, this is the hash of the previous. So this is how my link is going to be maintained. Clear? So this is a very important concept which you have to observe. See this hash and how hash of the previous block are calculated and linked. Without this, I cannot make a blockchain. Okay? The first block is going to be called as a genesis block. My first block is going to be called as a genesis block. Assume I have tampered the information in the second block. I have tampered the information in the second block. When I tamper the information, means data in the second block, what is going to happen? What is going to happen? Can anybody say what is going to happen? If the data is changed in the second block, my hash is going to change. I said right? If data is changed, automatically the hash is also going to be changed. Means it is not the same block, it is some other block. Okay? So if my hash is going to be changed, can I say this? Instead of 6BQI, something else, H62Y. Yes? Then what is happening? So, is these two are matching? Is these two are matching? No, right? Means the block chain is not there now. The chain got collapsed. Yes? Means this is not the true blockchain which I really thought of. Okay? So in turn, we make the block 3 and all following blocks invalid because there is no longer store a valid hash of a previous block. So from here onwards, if I have even 100 blocks, that complete blockchain is an invalid blockchain. So you understood the bit of it now? If I tamper any data that is there in any block, I am not even talking about one particular block, any block in that particular blockchain, if it is tampered, automatically the hash is going to be recalculated. Because hash is going to be recalculated, the chain cannot be established. Clear? So that is the beauty of a blockchain. So changing a single block will make all following blocks invalid. So, but using hashes is not enough to prevent tampering. So computers these days are very fast and can calculate hundreds of thousands of hashes per second. So what if I calculate the hash of all the blocks? Recalculate the hash of all the blocks. What is going to happen? Again I can make it valid. So then my purpose is not getting solved, right? My purpose is to make any blockchain very valid, and I am not supposed to tamper the data. I am not supposed to change any data in my block. But if my computers are so efficient that I can change the hashes of complete blockchain, if I can make it valid, the purpose is not solved. So then what is the solution for that? You could effectively tamper with the block and recalculate all the hashes of other blocks to make your blockchain valid again. But why? I am not solving my purpose. So then the concept of a proof of work has come into the picture. What does it say is, so to mitigate this, blockchain have something called a proof of work. Slow and steady wins the race, the tortoise story. Okay? It is a mechanism that slows down the creation of new blocks. It is not very easy to add a block into the blockchain. If I have to really add a block into the blockchain, there is a lot of process that is involved. Okay? And it is not going to be in one place. I will show you that as well. It is not going to be in one place. Okay? So if it is going to take good amount of time, then changing the other things is also not easy. If I have to add means the hash is going to be calculated from the complete blockchain, and if anybody wants to tamper in between, it is not going to be easy because of this proof of work concept. So for everything to happen, I am just giving a number. It may not be the exact number. It differs from blockchain to blockchain. But if we say 10 minutes, it is going to do. If there are 100, it is going to take 1000 minutes, right? So 1000 minutes is not a small thing. By the time, if anybody wants to access it, if it is not accessible, they feel that there is something going wrong with that. So they can understand that something is going wrong and they may start investigation on that particular stuff. So in Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. So it is not easy. First one is the data, when you tamper it, automatically the hash is going to be changed. Because of that, my chain is going to be invalid. Second thing, there is a proof of work concept where it takes, if you really want to change anything, it takes good amount of time within which the people can identify that there is something wrong going with that particular blockchain. So this mechanism makes it very hard to tamper with the blocks, because if you tamper with one block, you will need to recalculate the proof of work of all the following blocks. So if there are 100 blocks, as I mentioned, it takes almost 1000 minutes, which is not a very easy thing. Okay. So even if they make this also possible. Okay, what is going to be, what is the alternative approach for this? Okay, say for example, if there is a blockchain with 100 blocks and they have taken 1000 minutes to tamper that. Okay, so then what is the other way to take care of this? That is called as a P2P network. What does it say is, so there is one more way the blockchain secure themselves that being distributed. So if you remember it, in one of the slides I have shown that blockchain as a distributed ledger. Means it is not a ledger which is sitting at one place. It got distributed to many people at many places. So even if I tamper it in one location, it doesn't mean that it is a valid blockchain. Say for example, if 10 people are there, if the data is distributed among all these 10 people, okay, if I tamper the data in one particular person's location, does it mean that that's a valid data? Because I'll get it checked with all other 9 people, right? So if those 9 people have the correct data, because of a democracy, we'll go with those 9 people, not with the one person who has tampered the data. Do you agree with me? Yes? Same is the logic that is implemented even in the blockchain. When someone joins this network, he gets the full copy of the blockchain. Means, as I mentioned, it is a distributed ledger. Say for example, ICICI Bank is there. They have the accounts. Each and every account, say for example, we call it as a one block. Okay. So, they have a blockchain for the complete India. For every account. So, say for example, they may have 20 crores accounts. I'm just giving an example. So 20 crore accounts will be, if I take one particular account as a one particular block, so 20 crore accounts will be 20 crore blocks. So 20 crore blocks, I'm not going to have it only in the centralized location which is there in Hyderabad, right? In Gachibowli, you might have seen ICICI building. It is a data center for them. So I'm not going to recite that particular data only in Hyderabad location. What I'll be doing it is, I'll be having the same copy with the Mumbai location, with Chennai location, with Bangalore location, with the Kolkata location and Delhi location, maybe in another 10 locations. So, if somebody, if the people or a chair, I mean even the manager, I can say as chief manager of ICICI Bank, I'm just giving an example, don't take me wrong. So if ICICI manager, chief manager of ICICI Bank in Hyderabad want to tamper, he can tamper only his data. Getting my point? But if that data is already distributed among all other places, if something is going wrong there, what happens? The data is going to be again cross-checked in other places and that is going to take effect. It is not the one which is already being tampered in. Getting my point? Okay, that is the beauty of this blockchain. So if the new block means any addition, if a new account is getting added, say for example, as we discussed, we take it as one particular block. If I have to add it, it has to be added to all the places. Yes? So the blue block a light blue, this particular block, right? If I have to add it, if not, I'm going to add it only in this. It is going to be added to everybody in the network. Yes? Each node then verifies the blocks to make sure that it has not been tampered with. Okay? So when this block has to be added, it has to get the hash of a previous block. If they don't get it, so it will not be linked. Means whatever the data that I am going to add, it is at first worthy. If it is not, I am going to add, I can't add it because if, say for example, if this data is tampered, means I cannot add it. If this data is tampered, I cannot add it. Means I will go with the majority. Okay? If my data is getting tampered in one particular location, it is not going to fit in. It cannot be fit in. Okay? Then I can say that this particular person who is having this blockchain is not a valid one. So this has to be investigated. Okay? That is how it is going to be worked. So each node that verifies the block to make sure that it has not been tampered with, then only it will be added. Okay? If everything checks out, each node adds this block to their own blockchain. That is called consensus. All the nodes in this network create consensus. Consensus is nothing but I am going with majority. Even if I have to change one particular day or one particular block of a blockchain, at least 2/3 majority, call it like that, 51% majority should be there. Then if they agree, then only they can do it. Or else it cannot be done. So they agree about the blocks are valid and which are not. Blocks that are tampered with will be rejected by other nodes in the network. So, to successfully tamper with a blockchain, you will need to tamper with all the blocks on the chain, redo the proof of work for each block and take control of more than 50% of the P2P networks. That is called as a P2P network which I have mentioned. Means, as a democracy, I have to convince 51%, minimum 51% of the people to change the complete blockchain to add anything. Even if I have to add a dot into the data which is already been there, I have to get a consensus from 51% of the volumes. Okay? So if 10 people are there, at least 6 people should agree. Yes, I am agreeing with this particular change. Then only they can change it, or else it's not. So this combination, see, first of all data, that hash combination, that the previous hash, that itself is giving security. Second thing, because my data is changed, hash is going to be changed. Second thing, proof of work. Even if I have to recalculate the hashes for each and every block which is there in the blockchain, then the recalculation is going to be very difficult. It's going to take a lot of time. The third thing is, it is not a centralized network. It is not in the centralized network. It is in a distributed network. The data is getting distributed to many people within that network. Even if I have to tamper it in one location, it is not going to have any value. Because if I have to get it validated with other set of the people, at least 51% of the people should agree. Okay? Only then we tampered block becomes accepted by everyone. This is almost impossible to do. So blockchains are also constantly evolving. So there is a concept called as a smart contracts. Smart contracts is nothing but contract, you know, right? Contract is nothing but these agreements are all we do, which means you deliver this, I pay this. One example of a contract, right? So every faculty has a contract with the management. I deliver my lectures for this many number of days, and you have to pay this much amount. Okay, students, they have a contract with the college, right? I am joining, I am paying the fees, and you have to deliver the courses. This is a contract. So, particularly in this digital world, there is a concept of a smart contracts. What it says is, you might have heard about a crowdfunding. Yes? Yes? Even for this event, you might have some crowdfunding, right? Students might be contributing some amount and they might be celebrating something, right? It is a crowdfunding. But what for you are contributing it? It is for some event. So you have a purpose for the event, right? You want the event to be celebrated in so and so way, so that you might have thought of this is the budget that I have to invest, and this is the money each and everybody has to contribute. Okay? even these days, even movies are getting built using crowdfunding. Means, say for example, RRR movie. Okay, RRR movie, they might have spent some thousands of crores, right? Hundreds of crores at least. Hundreds of crores. Are you ready to invest in RRR? We are sure it is going to be successful. Or what are the reasons? Because of the past experiences that we have with the same director and the actors, right? We are ready to invest. Even if it is not 1,000 rupees, we are ready to invest. And if it is successful in the sense, if it has generated 2x of revenue, 3x of revenue, if you are going to get that money back. See, if you are investing 1,000 rupees, means you have maybe a 0.0001% of that share, yes or no? And if the movie is successful, then you may get 2x, 3x, 4x or 0.5x. So that is going to be written in my contract. You don't know Rajamouli, you can't approach Rajamouli and give that contribution of 1,000 rupees. But going forward, this is how the movies or whatever the companies are going to run in this way. Okay, the contracts is going to be in the form of slot contracts and based on the conditions that I have it. So if the movie is successful, automatically 2x money is going to be deposited in your account. That is how these contracts can be built. Okay. These contracts are simple programs that are stored on the blockchain and can be used as automatically exchange coins based on certain conditions. That is what I mentioned. Even if we contribute to a movie,